Welcome to Pratham Science Academy classes, and we are about to start with paper code 6531. This is the first subset of third series. And to start with section A, which is which has MCQs of 1 marks each. And our first question is it says that A is equal to AIJ is an identity matrix. Then which of the following is true? So we know that identity matrix is a diagonal matrix in which all the diagonal elements are 1 and all other elements are 0. So identity matrix, let me consider first of all, it's a square matrix. Square matrix means the rows and the elements are same. So let me go ahead and take an example of order 3 matrix. So its diagonal elements are 1. So that is 1 0 1 0 0 0 1. So this is an identity matrix of order 3. And in this identity matrix, so this element is the principal diagonal element, which is A11. This is A22, and this is A33. So now you can observe that all the principal diagonal elements, that is A11, A22, A33, is equal to 1. That is when this 1 is the row and this is the column. That is when all the rows and the columns are equal, the element is 1. And these are A12, A13, this is A21, this is A23, A31, A32. Now for all the elements where I is not equal to j, the elements are 0. So this match with the option D. So all the elements, diagonal elements are 0. Sorry, all the non-diagonal elements are 0. That is, I is not equal to j, and it's 1 when I is equal to j. Moving on to question number 2. Okay, for question number 2, it's given that R plus, it denotes a set of all negative real numbers. That is, this function is defined from set of all positive real numbers to set of all positive real numbers, and the function is x squared plus 1. And we have to check. So it's 1 1 on 2 are the options. So let's check it for 1 1. And for 1 1, we know that function is 1 1 when for every x there is a unique 1, that is f of x. For every x2 there is. Okay, so what we will do, we will consider that these two are equal and these two are also equal, that is they are not different. And for that, let's say x1 and x2 belongs to the domain of positive real numbers, in the f of x1 is equal to f of x2, let so which gives x1 square plus 1 is equal to x2 square plus 1. This gets cancelled. Now x1 square is equal to x2 square, which gives us x1 is equal to plus minus x2, but we have to take only the positive number, so that means x1 is equal to x2. So that means if the images are same, then these three images or the uh, x are not different, they are also same, which gives us that the function is 1. Now let's check it for onto, and function is onto when function is onto when we have for every y means a value of x. So our function is f of x is equal to x squared plus 1. Now f of x means it's the output y. Okay, so From here, x squared is equal to y minus 1 and x is equal to root of y minus 1. Now, let's find out f of root of y minus 1, and which gives me root of y minus 1 the whole square plus 1, which is equal to y minus 1 plus 1, that is equal to y. That is, for every y which belongs to R plus, there exists a value x that belongs to codomain such that f of x is equal to x squared plus 1. Okay, so therefore this function is onto. So function is both onto and 1, 1. So both 1, 1 and onto. Let's move on to question number 3. Okay, sorry, for question number 3. It's given that adjoint of A is equal to A, then we have to find the value of A plus C plus D. Now A is a square matrix of order 2, and to find its adjoint, there is a shortcut for to find the adjoint of a square matrix of order 2. Just swap the positions of these two elements, D, A, and change the sign of these two elements. If it's negative, change it to positive. It is positive, change it to negative. So both these are positive, so I have changed it to negative. Now it's given that adjoint of A is equal to A. So D negative D, let's equate these two matrices. And when two matrices are equal, that means their corresponding elements are equal. So now A is equal to B, negative B is equal to negative B is equal to negative B. That means B plus B. So A is equal to D and negative B is equal to negative B. So that means negative B is equal to 0. So that means B is equal to 0. Now negative C is equal to negative C. That means negative C is equal to 0. Negative 2C is equal to 0. C is equal to 0. Now A is equal to D. So let's now find out the value of A plus B plus C plus D. So A plus B plus C plus D. Now A and D are equal. Now B is 0, C is 0, and D and A are equal. So I can assign the value A. So this is 2. So 2A is the correct option for question number 3. And we are to question number 4. Okay, for question number 4, it's given that f of x is equal to modulus of 1 minus x plus modulus of x, and this whole is modulus. Now we have to check its continuity. So our given function is f of x is equal to modulus of 1 minus x plus modulus of x. Now we know that the modulus function is negative x, or it's x when x is greater than equal to 0, and it's negative x when x is less than 0. So let's try to break this function for these two values of x. So this function becomes 1 minus x plus. Now, for when x is greater than equal to 0, this modulus of x is x, and this gets reduced to 1, and it's 1 minus x. When x is less than 0, this value is negative x when x is less than 0. So finally, our function, it gets break into, so modulus of 1 is 1. So when x is greater than equal to 0, the value of the function is, this function breaks into two values, 1 and the other value is modulus of 1 minus 2x when x is less than 0. Okay, let's check this. Now here x is less than 0, that means the value of x will be negative. So if we take any negative value, which will give us anyhow the positive value, so we can write that this is positive. So our function gets broken into two parts. First one is when x is greater than equal to 0, its value is 1, and it's 1 minus 2x when x is less than 0. So finally, our function is 1 when x is greater than equal to 0, and 1 minus 2x when x is less than 0. And we have to check the continuity of this function. So our function has, when x is less than 0, it's 1 minus 2x and 1. Now we have to check the continuity of this function at x is equal to 0. Now f of 0 means equal to 0, the value of the function is 1. Now let's check its left hand limit. So left hand limit is limit x tends to 0 negative f of x, and the value of the function for x is less than 0 is 1 minus 2x. So this limit x tends to 0 negative 1 minus, this is 1 minus 2x. And let's say now that x is equal to a small value h less in 0. So as x tends to 0, h tends to 0. So let's change this limit to limit h tends to 0. It is now 1 minus 2 into 0 minus h, which gives me limit h tends to 0. This is 1 minus 2 into 0 is 0 plus 2h. And if we take the limit, that is, if we put the value of h is equal to 0 here, this is 1. So left hand limit is 1. Let's find out the right hand limit. So right hand limit is limit x tends to 0 plus f of x. And for value of x greater than 0, the function is 1, so it's 1. It's 1. Now the value of the function left hand limit and right hand limit all are equal to 1. So that means the function is continuous function. So this function is continuous everywhere, and we can choose the option D, which says it's continuous everywhere. Moving on to question number 5. Okay, for question number 5, it's given that the sides of a square are decreasing at the rate of 1.5 centimeter per second. The rate of decrease of its perimeter is. Okay, now what's given to us is that let S be the side of the square, and rate of decrease means that it's decreasing. It's, let's say it's negative 1.5 meter per second. We have to find the rate of decrease of its perimeter, that is dp by dt, p with the perimeter, and we know that the perimeter of the square is given by 4 into side, 4 is out, so it's ds by dt, and we know that ds by dt is negative 1.5, it gives me negative 6 meter per second. Negative is for the decrease, and our option is option B. Moving on to question number 6. Okay, for question number 6, it's regarding one of the property of the definite integral, which is negative a to a f of x into dx. And this property says that it's 0 to a f of x into dx when f of x is even, and this is equal to 0 when f of x is odd. Now, f of x is even when f of negative x is equal to f of x, and it's odd when f of negative x is equal to negative f of x. So it's given that it's equal to 0, and it's equal to 0. This is equal to 0 when f of x is odd, and f of x is odd when f of x is equal to negative of f of x. B is the correct option. This is one of the property of the definite integrals. Moving on to question number 7. Okay, for question number 7, we have to show that x into log x dy by dx plus y is equal to 2x log x is an example of. So our differential equation is x log x dy by dx plus y is equal to 2 log x. And if we divide each of these terms with x log x, so this is dy by dx, x log x divided by x log x, plus y upon x log x is equal to 2 log x upon x log x. So this is now equal to, so this is now dy by dx plus y upon x log x is equal to 2 by x. Now, if we compare this with the dy by dx plus py is equal to q, so this is of the form. So this is p and this is q. So, and this is a linear equation. This is a linear equation of first order. So this is of the form dy by dx plus py is equal to qn, which is a first order linear differential equation. So our answer is C for this one. Okay, for question number 8, it's two vectors A and B are given. Then we have to check whether A and B are collinear vectors, parallel, perpendicular, or unit vectors. So it seems that if we find the dot product of these two vectors, this is A dot B. So A dot will be 2 into 1 plus negative 1 into 1 plus 1 into negative 1, which is 2. And this is negative 1, which is 2 minus 2 is equal to 0. And we know that if the dot product of two vectors are 0, then A vector is perpendicular to B vector. So that means these are the perpendicular vectors. Okay, for question number 9, it's given that alpha, beta, gamma, the angles which a line makes with coordinate directions of x, y, and z axis respectively, then which of the following is not true? Okay, and if we have these three axes, coordinate axes x, y, and z, and if let's say this is x, y, and z, and there is a line, so let's suppose this is a line, and it we know that the angle the angle that it makes with the positive direction of x-axis is known as alpha, with y-axis beta, and with z-axis it's gamma. And square of the cosines of these angles is always equal to 1. So this is the relation between the cos of the angles that a line makes with x, y, and z axis respectively. So the first one is true. Now the cos square alpha, I can write it as 1 minus sine square alpha plus 1 minus sine square beta plus 1 minus sine square alpha is equal to 1. So 1 and 1 gets cancelled. So this is now, for all these, I can take negative common. So this is sine square alpha plus sine square beta plus sine square gamma, that is equal to, now 1 plus 1 is 2, and taking it to the side it's negative 2 to negative gets cancelled. So this statement is the second. So this is true, this is true. Now let's check if you can get cos 2 alpha. Now cos square alpha, we know that cos 2 alpha is equal to 2 cos square a minus 1. So that means cos a, I can write it as 1 plus cos 2a by 2. So that means instead of cos square alpha, I can write 1 plus cos, this is 2 alpha, 2 alpha by 2. And this also gets changed to 1 plus cos 2 beta by 2 plus 1 plus cos 2 gamma by 2, that's equal to 1. Now taking LCM 2 and taking it to the right hand side, it's 2. So we are left with cos 2 alpha, cos 2 beta, cos 2 gamma. So this is cos 2 alpha, cos 2 beta plus cos 2 gamma. and 1 plus 1 plus 1 is 3, so 2 minus 3 is negative 1. So this statement is equal to negative 1, which is also true. Now the only option left is D, so that means obviously this is going to be false. So D is the correct option, which is not true. Okay, for question number 10, we are asked what are the restrictions imposed on decision variables involved in an objective function of a linear programming problem call. So these are constraints, and you might have noticed that the objective function is given by it's 10x plus 5y, something like this. And there are the restrictions like 2y plus x plus 2y is greater than equal to 0, 3x plus 5y is greater than equal to 10. So these are the restrictions and are called constraints. And you will find issue more like x is greater than equal to 0, y is greater than equal to all these are restrictions and called constraints. Moving on to question number 11. For question number 11, E and F are two even such that probability of E is zero point 0.1, F is zero point 0.3, and probability of E and F is zero point 0.4. Then we have to find the probability of F by E. And we know that probability of F by E should be probability of F intersection E divided by probability of E. That means we have to find probability of intersection E. And let's use this formula. Now, probability of E union F is given by probability of E plus probability of F minus probability of E intersection F. Now, E union F is zero point 0.4. Probability of E is zero point 0.1. Probability of F is zero point 0.3 minus probability of E intersection F. Now, this is zero point 0.4 is equal to zero point 0.4 minus probability of E intersection F will give me probability of E intersection F is equal to 0. The probability of E intersection F and F intersection is the same thing, so it's 0 by probability of E is zero point 0.1, so this is equal to 0, so D is the correct option. Okay, for question number 12, it's given that A and B are two skew symmetric matrices, then AB plus BA is one of the following. So a skew symmetric matrices means that transpose of A is equal to negative of A and transpose of B is equal to negative of B. So that's the meaning of skew symmetric matrices. Now let's try to find the transpose of AB plus BA, the whole transpose, and we are going to use the property A plus B, the whole transpose. We know that is equal to A transpose plus B transpose. So this should be equal to AB transpose plus BA transpose. Now, there is one more property that says that AB, the whole transpose, is equal to B transpose A transpose. So this becomes B transpose A transpose, and this becomes A transpose B transpose. So B transpose is equal to B A transpose is negative A. A transpose is negative A. B transpose is negative B. So this is equal to AB plus So this is equal to BA plus AB, and I can write it as AB plus BA. So that means the transpose of A plus BA is equal to the matrix itself, that is AB plus BA. And we know that when the transpose of the matrix is equal to the matrix itself, then it's a symmetric matrix. So that means AB plus BA, the whole transpose is a symmetric matrix. Okay, for question number 13, it's given that determinant of this is equal to plus or minus 6. So we are given that determinant that is 1, 3, 1, K 0, 1, 0, 0, 1 is equal to plus minus 6. So let's expand it along row R3 because we have two zeros, so it's easy to expand it along R3. So this is plus, minus, plus, minus, plus. So 1, and removing the row and the column for element 1, we are left with 1, 3, negative k, and 0, that is equal to plus minus 6. So, which is now equal to, uh, this is not actually negative. I have just, this was actually k. So, this is k is equal to 0. I'm just assigning the signs. It starts with positive, negative, positive, negative, positive. So, this one has to be positive 1. Okay, so this becomes 1 into 0 is 0, and k into 3 is negative 3k is equal to positive negative 6. So minus 3k is equal to positive negative 6. And now because it's negative, so if we multiply, first take negative, so this become positive becomes negative, and negative becomes positive, and if we divide it by 3, so this is equal to 2. So k is equal to negative positive divided by 2. Let me show you how this is. So first of all, because it's positive, so we will take plus 6, which gives me it's negative 2. And that's if we take negative, which becomes k is equal to 2. So the first one is negative, and the second one is positive because it's given that the first is positive, so we have to take the positive value first, which gives me negative 2, and negative 6 is has to be taken secondly, so which gives me positive 2. So k is equal to negative positive 2 is the answer. Moving on to question number 14. Okay, for question number 14, we have to find the derivative of 2 raised power x with respect to 3 raised power x. So this is 2 raised power x. We have to find the differentiation of this with respect to 3 raised power x. So let's consider this as y and this as z. And their differentiation means that we have to find dy by dz. Okay, so we are going to differentiate both of these two with respect to x. So differentiating this with respect to x. So this is dy by dx, and this is the formula of differentiation of a raised power x. Differentiation of a raised power x is a raised power x into log a. So this becomes a raised power x into log a, which is 2. Similarly, this differentiating this with respect to x, we get dy by z. If dz is equal to 3 raised power x into log 3. Now we have to find dy by, sorry, this is actually dz by dx, z with respect to x. So we have to find dy by dz, that should be equal to dy by dx divided by dz by dx. This is equal to 2 raised power x log 2 and 3 raised power x log 3. This is equal to 2 by 3 raised power x log 2 by log 3, and which is option C. So C is the correct option for this. Okay, for question number 15, it's given that modulus of A is 2 and K is between negative 3 and 2, where negative 3 and 2 are included. So what is the value of modulus of K into A vector? So K A vector's modulus. Now K into A vector's modulus, I can write it as K. So this can be written as K modulus of K into A. Okay, so this can be written as modulus of K into. Now, uh, the minimum value of K is negative 3. So let's take K is equal to negative 3, which gives me K is modulus is equal to negative 3's modulus and A's modulus is 2. So negative 3's modulus is 3 into 2 is equal to 6. And let's say when K is equal to 0, so this becomes 0 into 2 is equal to 0, and let's take the highest value, which is 2. So when k is equal to 2, this is k into a vector's modulus, so modulus of k into A is modulus, and K is now 2A is 2, which is equal to 4. Now, here the minimum value is 0 and the highest value is 6. 4 comes in between 0 and 6. So that means K belongs to 4 and 6 are included. So K belongs to, sorry, 0 and 6 are included between 0 and 6 for the closed interval. So D is the correct option for question number 15. Okay, for question number 16, it's given that if a line makes an angle pi by 4 with the positive direction of both x and z axis, now with x-axis, the angle made is taken as alpha, and with y-axis, it's beta, which is not given, and with z-axis, it's gamma, it's also pi by 4. Now, we know that cos square of cosines and squares of these all angles when added gives us 1. So this is cos square gamma is equal to 1. Now, cos square alpha is cos square pi by 4 plus cos square beta plus cos square pi by 4 is equal to 1. Now cos pi by 4 is 1 by root 2 square. This is cos square beta plus 1 by root 2 the whole square is equal to 1. So this is half plus cos square beta plus half is equal to 1. So half is 1. So this cos square beta is equal to 0. And we know that the angle for which, so that means cos square beta is 0. So that means cos beta is 0. And the angle for which value of cos is 0 is cos pi by 2. So that means beta is equal to pi by 2. And C is the correct option for this. Okay, for question number 17, we have to check which group of these constraints represents the feasible regions, and we have only two equations. So this line is, for this line, the equation is 2x plus y is equal to 104. Now, to get the common region for this, it should be towards, its feasible region should be towards the origin. So that means here it should satisfy this coordinate 0 comma 0. So that means 2x plus y is equal to 104 should be, uh, if I put 0 here, so 0 is less. If I put this coordinate in this, which gives me 0, so 0 is less than 104, so this should be less than equal to 104. This is the first one. Okay, for the second equation, it's x plus. So for the first inequality, our solution region is towards the origin. And to get the common region for the second line, its solution region should be away from the origin so that we can get this as the common region. So equation is x plus 2y is 76, and it should not satisfy this coordinate 0 comma 0, that is 0 should be, it's greater than 76, which should be, which is false. So it should be greater than equal to 76 so that we can get its feasible region away from the origin. And now this is our common region. So this matches with 2x plus y is less than equal to 104, and x plus 2y is greater than equal to 6. So C is the correct option for this. And if we take these constraints, our feasible region will be this one. So C is the correct option for this. Okay, for question number 18, we have to find the A inverse of the matrix. And to find the A inverse, either you can use A inverse is equal to adjoint of A by determinant of A. So let's use this method, or uh, alternatively, you can use this property that says that A into A inverse is equal to I matrix, identity matrix. So that means if, so A inverse is out of these, so you can multiply A any of these and check if it's an identity matrix, then one of these will be the A inverse. So you cannot go ahead and multiply each one of these, or so let's use this adjoint A by A method. and A in, so first of all, let's check, find out a determinant of A. So determinant of A can be, uh, we can find that using by expanding this matrix along row R1. So let's assign this is positive, negative, positive. So it's just 2. So 2, removing the row and the column for 2, we are left with 3005, which gives me 2 into 5 threes are is 15. And so which is equal to 30. Now let's find out the adjoint of A. To find out the adjoint of A, let's find out the cofactors A11, A12, A13. So A11 would be removing the row and the column for, so this is positive, this is negative, and this is positive. So removing the row and the column for the first element, we are left with 3005. So 3005, and this is now 1 to remove the row and the column for the second element in the first row. It's 0005. So 0005, and then it's A13. So removing the row and the column for this is 0300. So this is 0300, which gives me 5 threes are is 15. This is 0. 0 into 5 is 0. This is 0. And this is again 0. And our cofactor matrix is 1500. Now let's find out the other elements. It's A21, 22, and A23. Cofactors A21, A22, and O23. So this is negative, this is positive, and this is negative. Remove the row and the column for the element in the second row and the first column. It's 0005. So 0005, and remove the row and the column for this one. It gives me 2005. So 2005, and remove the row and the column for 23. It's 2000. So 2000. So this is 0, this is 10, and this is 0. So it's 0, 10, 0. Okay. Now let's find out A31 and A32. So A31, A32, and A33, this is positive, this is negative, and this is positive. Okay, A31. Remove the row and the column for A31. It's remove the row and the column for A31, 0030. So this is 0030. This is 2000, and this is 33. So this is 2003. 2003, which gives me, this is 0, this is once again 0, and this is equal to 6. So 006, 006, and we have to find the transpose for this to get the adjoint of A. So adjoint of A is the transpose of this, which is 15, 0, 0, 0, 10, 0, and 006. So this is the adjoint matrix, and we have to find the A inverse, which is adjoint of A divided by the determinant of A, and determinant of A is 30. So let's divide it by 30, which gives me 15, 0, 0, 0, 10, 0, 006. And finally, it's 15 divided by, divide every element with 30. So this becomes 1 by 2, 0, 0, 0, uh, divided with 30. So this is 3, 0, 0, and this is 1 by 5. So 1 by 2, 1 by 3, and 1 by 5. So 1 by 2, 1 by 3, 1 by 5. A is the correct option for this. Okay, for question number 19, which is based, uh, and we have to check out of these four options which is the correct one. Now let's check the assertion which says that every scalar is a diagonal matrix. So let's try to understand what is a diagonal matrix and what is a scalar matrix. So diagonal matrix is a square matrix which has the principal diagonal elements non-zero and other elements are zero like. So diagonal matrix has principal diagonal elements. So let's consider a square matrix of order 3. So I will just put the diagonal elements as 1, 2, 3, and put all other elements as 0. So this is a diagonal matrix in which all the principal diagonal elements are non-zero. Now every scalar matrix. So every scalar matrix is 1. So what is a scalar matrix? So scalar matrix is a diagonal matrix in which all the principal diagonal elements are some values, let's say k, and all other elements are 0. So in the diagonal matrix, so all principal diagonal elements are scalars. So that means that every scalar matrix is a diagonal matrix which is true. So this one is true. Now in a diagonal matrix, all the diagonal elements are 0, which is false because all the diagonal elements are non-zero. So for this, C is the correct option. Assertion is true, but reason R is false. So option C is the correct one for this. Okay, for question number 20, is again the assertion and the reason base. Now the projection of A and B same as projection of B on A. We have to check that. Projection of A on B is given as dot product of A, B divided by A on B divided by B's magnitude. And the projection of B on A is given by B dot A divided by the magnitude of A, which is not equal. Now I can write B dot A as A dot B upon A. So this is a projection of A on B, and this is a projection of B on A, which are not equal. So that means this statement is false. And let's check that now the reason. So projection of A on B is A dot B divided by the magnitude of B, and projection of B on A is B dot A divided by the magnitude of A, which becomes A dot B divided by magnitude of A because A dot B is equal to B dot A, which is commutative. Now coming on to the reason, angle between A and B. If we have to find the angle between A and B, we can use the dot product, which is magnitude of A into magnitude of B into cos theta. Let's say cos theta is the angle between A and B. Okay, so which gives us cos theta is equal to A dot B upon magnitude of A into magnitude of B. Now let's assume that the angle between A and B is theta and angle between B and A, let's assume it's alpha, and which can be, so let's find out the dot product of B and A, which gives me magnitude of B into magnitude of A into cos alpha, which gives us cos alpha is equal to B dot A divided by magnitude of B into magnitude of A. Now B dot A is commutative, so I can write it as A dot B, and this I can rearrange and write it as A magnitude of A into magnitude of B. So this is 2, this is 1, which means cos theta is equal to cos alpha, which means theta is equal to alpha. So that means the angle between A and B same as the angle between B and A. So this is true, but this is not the correct explanation of A. So we can only say that assertion is false, but reason R is 2. So D is the correct option for this one. Okay, for question number 21 and 25, these are very short answer questions of 2 marks each, and we have to evaluate this. So this is secant square tan inverse of half, and we know that 1 plus tan square theta is equal to secant square theta, and here theta is this. So I can write it as 1 plus tan square, and theta is tan inverse of half. Similarly, cosecant square, we know that 1 plus cot square theta is equal to cosecant square theta. So this can be written as 1 plus cot square in of cot inverse 1 by 3. Now this is tan, I can write this as tan inverse of half the whole square plus 1 plus this is 1 plus cot of cot inverse 1 by 3 the whole square. So this becomes half. This is equal to half square, and this is equal to 1 plus 1 by 3 square, which is 1 plus 1 is 2. This is 1 plus, okay. Now the LCM is 36, which gives me 72 plus 9 plus 4. So 72 plus 13 by 36. And the answer should be 85 by 36. So 85 by 36 is the answer for this. Let's move on to question number 22. Okay, for question number 22, part A, our given function is x is equal to e raised power x by y. Why we have to prove that. So let's write down our function x is equal to e raised power x by y. Now this is the e raised to the power some function. So let's take log on both sides. So taking log on both sides we get. So this is now log x, and this is equal to log e raised power x by y. So this is of the form log m raised power n, which is equal to n log m. So this becomes log x is equal to x by y into log e. So this is the natural log, which becomes 1. And finally, we have log x is equal to x by y. Let's cross multiply this, which becomes x upon log x, which is now easier to differentiate. So differentiating with respect to x now. So differentiating with respect to x. Differentiation of y is dy by dx, and this is the quotient rule. So this is uv. So v into differentiation of x, which is 1, minus u into differentiation of v, which is 1 by x upon v the whole square, using the quotient rule. So we have used the quotient rule here for the differentiation. So finally dy by dx is equal to log x minus this is 1 upon log x the whole square. So dy by dx is equal to log x minus 1 upon log x the whole square. Okay, for next question, we have to check the differentiability of the function at x is equal to 1. And this function is defined at x is equal to 1 as for the left hand limit, the value is for the value between 0 and 1. Value between 0 and 1, the function is defined as x squared plus 1, and between 1 and 2, function is 3 minus x. Now let's check the differentiability of the function. So for that, let's find out the left hand derivative, which is equal to limit, because we are checking this function at x is equal to 1. So limit x tends to 1 negative f of x minus f of a upon x minus a. And a here is 1. So this function becomes limit x tends to 1 negative. This is f of x minus f of 1 upon x minus 1. Okay. For अभी छुट्टी करो no शाम को आ जाओ. Okay, now value of the function when it's less than 1 is x squared plus 1. So f of x is x squared plus 1. So this is limit x tends to 1 negative. This is x square plus 1, and value of the function at 1. The value of the function at 1 is equal to, at 1 is equal to, value of the function is 3 minus x, and x is 1, so this is equal to 2, so this is 2 upon x minus 1, which becomes limit x tends to 1 negative. This is x squared minus 1 upon x minus 1, and this is limit x tends to 1 negative. This is a squared minus b squared, so a minus b into a plus b upon x minus 1, which gives me x plus 1. So this is limit x tends to 1 negative x plus 1, and let's assume that x is equal to small value h less than 1, and as x tends to 1, h tends to 0. So this is now limit h tends to 0. This becomes, x is now 1 minus h plus h, which is equal to, if we take the limit for h is equal to 0, it gives you the value. Now let's find out the right hand derivative, which is equal to limit x tends to 1 plus, and it's f of x minus f of a, which is 1 upon x minus 1. Okay, so this is limit x tends to 1 plus. Now f of x for value greater than 1, f of x is 3 minus x. So this is 3 minus x, and the value of the function at x is, at x is equal to 1, the value function is 2. So this is 2 upon x minus 1. So this becomes limit x tends to 1 plus upon 3 minus, and this is uh, for x greater than 1, the value of the function is 3 minus x, and f of 1 is 2 upon x minus 1. So this is now, this is actually minus 1. So this is minus 2. This is minus, so minus 2, 3 minus 2 is 1 minus x upon x minus 1, and I can write it as limit x tends to 1 plus, this is negative x minus 1 upon x minus 1, and x tends to 1 plus, this is negative 1, so this is 1. Now left hand limit is not equal to right hand limit, because at this the value of the function is 2, and at right hand limit the value of the function is 1. So the function is not differentiable at x is equal to 1. So this function is not differentiable at x is equal to 1. Okay, for question number 23, part A, we have to evaluate the given integral. Let's say this is I, and to get this into some known form, let's multiply and divide it with 2. So this is now 2 sine A cos B, which is equal to sine of A plus B plus sine of A minus B. And if we use this formula, our integral I is now equal to half 0 to pi by 2. Now 2, this is sine of A plus B. A plus B is, this is A and this is B, which is 5x, plus sine of A minus B. So 2x minus 3x is negative x. And we know that sine of negative x is equal to negative sine x. So this becomes a negative sine x. So this is now negative sine x into dx. Okay, so let's do the integration now. So integration of sine is negative, this is cos 5x, and this has to be divided by 5, minus integration of sine is negative cos x. So this becomes positive. So this is now minus, minus is plus, so this is plus, and let's now evaluate it for pi by 2. So I is equal to 1 by 2 minus cos 5 into pi by 2 divided by 5 plus cos pi by 2 minus. This is now negative cos 5 into 0 divided by 5 plus cos 0. Okay, now let's evaluate. This is negative half. Let's evaluate cos 5 pi by 2 because cos 90 is 0. So this is 0 now. Cos of 5 pi by 2 is equal to cos 5 into pi by 2 is 90. So this is equal to cos 450, which can be written as cos 90 into 5 plus 0. Okay, so 5 means it changes to sine. So this is sine 0, which is equal to 0. Okay, so this is 0 by 5 is 0. So this is 0 minus. Now cos 5 into 0 is 0 and cos 0 is 1. So negative 1 by 5 plus cos 0 is 1. This is now equal to, so I becomes equal to, so half into 0 is 0. So this term reduces to 0. Sorry, this is half and this half is for the whole term. So this is negative half and this is 0. So now minus 1 by 5 plus 1 is 4 by 5, which becomes, this is not negative, this is actually positive. So this is negative and negative 1 by 5 plus 1 is 4 by 5. So 2 2s is 4 and our answer is negative 2 by 5. So the given integral's value is negative 2 by 5. For question number 23rd, part B, it's given that the differentiation of f of x is equal to 1 upon uh, under root 2x minus x square, and we have f of 1 is 0 and we have to find the value of f of x. So differentiation of f of x by x. So this is differentiation of f of x is equal to 1 upon under root of 2x minus x squared into dx. And let's take the integration on both sides. So taking integration on both sides will give us, so let's take taking integration on both sides we get. So this is the integration of d of f of x is equal to integration of 1 upon under root 2x minus x square into dx. Now integration of d by dx is f of x. So this becomes f of x, and let's try to simplify this now. 2x minus x the whole square into dx. So let's consider this. This is 2x minus x, 2x minus x squared. Okay, so 2x minus x squared can be written as a negative of x squared minus 2x. And let's complete the square for this. So let's add and subtract square of 1 in this, which gives me negative. So this becomes x minus 1 the whole square and negative 1 square, and this can be now written as 1 square minus x minus 1 the whole square. Okay, so 2x minus x the whole square is equal to this. So let's substitute the value. So f of x is now equal to 1 upon under root 1 square minus x minus 1 the whole square into dx. Now we know that under root integration of under root a square minus x square is equal to sine inverse x by a plus c. So this becomes f of x is now equal to integration of this is not integration. we are going to apply this formula. So this becomes sine inverse x is x minus 1 and a is 1. So let's leave that plus c. Now f of x means y. So this is sine inverse x minus 1 plus c. Now let's go back to the question, and it says that f of y1 means if we put x is equal to 1, it gives me the value y is equal to 0. So we can say that when x is equal to 1, y is equal to 0. So this is 0. And now sine inverse 1 minus 1 plus c, which gives me 0 is equal to sine inverse 0. Now sine inverse 0 is 0, so c is equal to 0. So our f of x, this becomes, now let's look the value of, so f of x is equal to sine inverse x minus 1, c is 0. So this is the value of sine inverse x minus 1. So we have got our f of x, which is sine inverse x minus 1. Okay, for question number 24, we have to find the position vector of point C, which divides a line segment on the point A and B, and whose position vectors are given. And it divides it in the ratio 4 is to 1 externally. Okay, so this is question number 24, and it's given that there is a line segment joining the points A and B. So let this be point A, and this point C. Now, position vectors of A are I cap plus 2j cap and negative k cap. Position vectors of B are negative I cap plus j cap plus k cap. Now, there is a point C externally on this line. Let's say this is point C, and this divides AB in the ratio 4 is to 1 external. So externally means that this is 4 and this is 1. So this is m is to n. So let's say this is m and this is n. So the ratio is m is to n. And this is point C, and we have to find the coordinates of the position vectors of the point C. Now the position vector of a point which divides a line segment in the ratio m is to n internally externally is given by m into b vector minus n into a vector upon m minus n. So putting the respective values, n is 4, so this is 4, and the position vector of b is minus I cap plus j cap plus k cap minus n is 1, and a vector is the vector of a is I cap plus 2j minus k cap upon n minus n, which is 4 minus 1. Okay, now finally the position vector of C. So this is the position vector of C of C. Now this is negative 4i cap plus 4j cap plus 4k cap minus I cap minus 2j cap plus 4 upon 3. So position vector is now minus 4 and minus 1 is minus 5 I cap. 4 minus 2 is 2j cap. 4 plus 1 is 5k cap, and this is the position vector of C, which is minus 5 I cap plus 2j cap plus 5k cap divided by 3. Okay, let's move on to the next query. It says that we have to find AB vector and BC vector and its ratio, the magnitude of AB and BC. So first of all, let's find AB vector, which should be the position vector of B minus position vector of C. Now B is negative I cap plus j cap plus k cap minus C. We have just, okay, it's not C actually. It's B minus E vector. So B is negative I cap plus j cap plus k cap minus position vector of A is I cap plus 2j cap minus k cap, and which gives me AB vector as this is negative 2I cap and minus j cap and plus 2k cap. And if I have to find the magnitude of AB, that should be the sum of the square of the scalar components. Negative 2 square is 4 plus 1 plus 4, which is equal to root 9, which is equal to root 2. Next is our BC vector. So BC vector is C vector minus B vector. Now C vector, position vector of C is this. So let me write it as minus 5 by 3 I cap plus 2 by 3 j cap plus 5 by 3 k cap minus position vector of V. So this is I cap plus 2j minus, sorry, position vector of V is minus I cap plus j plus 2. So this is minus I cap plus j plus k cap. Let me open up the bracket and simplify this. Minus 5 3 I cap plus 2 3 j cap plus 5 by 3 k cap plus I cap minus j cap minus k cap. Okay, negative 5 by 3 plus 1 is negative 2 by 3 I cap, and 2 by 3 negative 1 is negative 1 by 3 j cap. 5 by 3 minus 1 is 2 by 3 k cap. Now we have to find its magnitude, which should be the sum of the square of the scalar components of BC vector, and this is now equal to 4 by 9 plus 1 by 9 plus 4 by 9. This is equal to 9 by 9, which is root 1. Okay, so this is the magnitude of V. Now let's find out its the ratio. The ratio of magnitude of AB is to magnitude of BC is equal to AB is 3. So this is 3 is to 1 is the required ratio. Okay, for question number 25, it's given that A and B are two non-zero vectors, and we have to prove that the modulus of A cross B is less than equal to magnitude of A into magnitude of B, and we have to state the condition under which this equality holds. Okay, now we know that A cross B is given by magnitude of A, magnitude of B into sine theta, and if we have to get the modulus, it should be like this. Now sine theta, we know that if we have take if we have to take the modulus of sine theta, it should be greater than or equal to 0 but less than equal to 1. Let's consider this inequality. So this is sine theta is less than equal to 1. Let's multiply it with magnitude of A and B on both sides. So magnitude of A into magnitude of B, and modulus of sine theta is less than equal to magnitude of A or the modulus of B. Okay, so for this inequality, or for this LHS to be equal to RHS, that is for equality, this sine theta should be equal to 1. And if sine theta is equal to 1, that means we can write here it's sine pi by 2. That means theta is equal to pi by 2. And when theta is equal to pi by 2, that means A vector should be perpendicular to B vector. So A vector should be perpendicular to B vector is the condition for this, for which this inequality holds good. So we have just proved that A Modulus of A cross B is less than equal to magnitude product of the magnitude of A and B when theta is equal to pi by 2. Okay, for section C, this is question number 26, part A, and we have to prove the differentiation for the following equation. And this is a three marker. So our equation is x into cos of p plus y plus cos p into sine of p plus y is equal to 0. So let's try to simplify this first, and it can be written as x into cos p plus y, and it's given that p is a constant. This is equal to negative cos p into sine of p plus y, and now x can be written as this is x negative cos p sine p plus y upon cos of p plus y, which is now equal to negative, and this is cos p negative cos p sine upon cos is tan. So this is tan of p plus y. Now let's differentiate this with respect to y. So differentiating this with respect to y, we get, so this is dx by dy. This is constant. P is constant, so this is out. And differentiation of tan is secant square p plus y, and differentiation of y is 1. Okay, so we have to find dy by dx. So let's make the reciprocal of this. So this is negative 1 upon cos p into secant square p plus y. And if we check what we have to prove, so this is cos p. So let's take it to the left hand side. So this is cos p into dy by dx is equal to negative. Now 1 upon secant square is cos square. So this is cos square p plus y. So cos p into dy by dx is equal to negative cos square into p plus y, where p is a constant, and this is what was asked to prove. Okay, for part B, question number, it's 26. So for question number 26, part B, we have to find the value of a and b for which the function is a continuous function. Now, we know that when the function is a continuous function, so value of the function, so this function is defined as at x is equal to 2, so value of the function at 2 should be equal to left hand limit is equal to right hand limit. And let's use this to find the value of a and b. First of all, now the value of the function at 2 is a plus b. So let's keep this. And now let's find the left hand limit of the function. So left hand limit of the function is at x is equal to 2 is x to negative f of x. That is equal to limiting x to negative now f of x. For left hand limit that is less than 2, the value of the function is, this is x minus 2 upon modulus of x minus 2 plus a. Okay, let's make the substitution here. Let's say x is equal to a small value h less in 2, and now as x tends to 2, h tends to 0. So this now becomes limit h tends to 0. For x, the substitution is 2 minus h minus 2 upon, this is 2 minus h minus 2 modulus plus a. So this is now equal to limit h tends to 0, negative h upon modulus of negative h plus a, which is limit h tends to 0, negative h upon h plus a, which is negative 1. So if we take the limit, this is negative 1 plus a. So left hand limit is equal to negative 1 plus a. Let this be equation 2. Let's find out the right hand limit. So right hand limit is written as limit x. So limit x tends to 2 plus f of x. Now the function for value of x greater than 2 is x minus 2 upon modulus of x minus 2 plus b. So this is limit x tends to 2 plus x minus 2 upon modulus of x minus 2 plus b. Now let's make the substitution here. Let's say x is equal to small value h added in 2. So this is 2 plus h. And as x, this x tends to 2, h tends to 0, which makes our limit as h tends to 0, make the substitution 2 plus h minus 2 upon modulus of 2 plus h minus 2 plus b. Okay, so this is now limit h tends to 0. We have h upon modulus of h is h plus b, which is 1. Now taking the limit gives me 1 plus b. So this is the right hand limit. Now here the left hand limit is equal to right hand limit is equal to value of the function, and this is the condition for the continuous function. For continuous function, now left hand limit is minus 1 plus a, right hand limit is 1 plus b, and value of the function at 2 is a plus b. So this is a plus b. So let's equate them one by one with a plus b. So minus 1 plus a, if equated to a plus b, gives me b is equal to negative 1. And if I equate 1 plus b, so if I equate 1 plus b equal to a plus b, which gives me a is equal to 1. So a is equal to 1 and b is equal to negative 1 are the values of a and b. Okay, for question number 27, part A, we have to find the intervals in which the function is strictly increasing or strictly decreasing. And our function is f of x is equal to log x by x. So let's differentiate this with respect to x first. So differentiating with respect to x. So differentiation would be this is f dash x, and we are going to use the product sorry quotient rule here. So this is v into differentiation of u, which is 1 by x, minus u into differentiation of v, which is 1 on v square, which is x squared. So now the differentiation is f dash x is equal to 1 minus log x upon x squared. Now let's find the critical points. So for maxima or minima, or for the increasing or decreasing function, f dash x should be equal to 0 for increasing or critical value. Let's find out the critical value of x. This f dash x should be equal to 0. And if I put f dash x is equal to 0, this is 1 minus log x upon x square is equal to 0, which gives 1 minus log x is equal to 0, or log x is equal to 1, which gives x is equal to e raised power 1. So that means our critical value is x is equal to e. Now let's find out the interval in which this function is strictly increasing. Now for strictly increasing function, f dash x should be greater than 0. So f dash x is, this is 1 minus log x upon x should be greater than 0. So this is 1 minus log x is greater than 0. If we take this to the right hand side, this is 0. So this gives us 1 is greater than log x, or log x is less than 1, or x is less than e. Okay, now x is less than e, and we know that the value of x is 2.17 something, 2.71. So this is value of E is 2.71 approximately. And to make sure that f dash x, this f dash x is 1 minus log x upon x squared should be greater than 0. Now, for strictly increasing, this should be greater than 0 and x should be less than 1. So this x should be less than e, that is 2.71. And but x can take only the positive, log x can take only the positive values. It has only the positive values. And for that, our x should also be greater than 0. Okay, so x should be greater than 0 and x should be less than e. So that means in, and it should not be equal to 0, because if I put this x 0 here, this becomes 1 upon 0, which is undefined. So it should not be equal to 0 and should not be equal to e. So that means for strictly increasing this function, for strictly increasing, x belongs to the open interval e to 0, or it's from 0 to e. So in this interval, the function is strictly increasing. Now let's go for strictly decreasing. Now for let's find out the interval in between which this function is strictly decreasing. For strictly decreasing, this f dash x should be less than 0. So if it's less than 0 and our first order differentiation is 1 minus log x upon x squared is less than 0, which gives us 1 minus log x is less than 0. So this is now 1 is less than log x, or log x is greater than 1. So that means x is greater than e. Okay. So x is greater than e. So that means in the open interval from e to infinity, function is strictly decreasing. So it's decreasing in this function e to infinity and increasing in the function 0 to e. Okay, for question number 27, part B, we have to find the absolute maximum and absolute minimum value of the function given by f of x on the interval 1 to 2. Close interval 1 to 2. So this is our function f of x is equal to x by 2 plus 2 by x, and differentiating this with respect to x gives this differentiation is 1 by 2, and 2 into differentiation of 1 by x is negative 1 by x square, and differentiation is finally minus 1 by 2 minus 2 by x square. Now for maxima or minima, first order differentiation should be equal to 0, which gives us negative 1 half minus 2 upon x square is equal to 0. So this is 2 upon x square is equal to negative half. And this is x square is equal to 4, which gives me x is equal to plus minus 2. But because we have to restrict to the interval 1 to 2, so this value is only 2, as it belongs to 1 and 2. Now we have the values 1 and 2, so let's find out the value of the function at 1 and value of the function at 2 to find the absolute maxima and minima. So value of the function is 1 by 2 plus 2 by 1, value of the function at 1. So this is 4, which is 5 by 2, and value of the function at 2 is 2 upon 2 upon 2 upon 2 plus 2 upon 2, which is equal to 2. So this is 2, this is 2.5. So this is absolute mean value, and this is 2.5. So this is absolute Maximum value is 5 by 2 and absolute minimum value is 2. Okay, for question number 28, we have to find the integration of x squared plus 1 upon x squared plus 2 into x squared plus 4. So let's try to get this into some standard form. And for that, I'm going to make the substitution. Let say x squared is equal to y. I'm not going to differentiate this. I'm just going to replace x squared with y so that we can get into the partial fraction method. So our this is now x squared plus 1 upon x squared plus 2 into x squared plus 4. This becomes y plus 1 upon y plus 2 into y plus 4. Right, okay. Now, this can be written as the partial fractions of this is y plus 1 upon y plus 2 into y plus 4 can be written as this is a upon y plus 2 plus b upon y plus 4. Okay, we'll try to get the value of a and b, and if we take the LCM, this is now a into y plus 4 plus b into y plus 2. This gets cancelled. So y plus 1 is equal to a into y plus 4 plus b into y plus 2. Now, how do we get the value of a? We will try to make this term 0 by putting y is equal to negative 4 in this equation, which gives me negative 4 plus 1 is negative 3. This term reduces to 0, and this is b into negative 4 plus 2. So this is negative 3 is equal to negative 2b, which gives me b is equal to 3 by 2. And similarly, if I put y is equal to negative 2 in this equation, which gives me negative 2 plus 1 is negative 1, and this is a, negative 2 plus 4 is 2. So this is a is equal to negative half. Okay, so that means this becomes a is negative half upon y plus 2 plus this is 3 by 2, so 3 by 2 upon y plus 4, and let's resubstitute the value of y, which is x squared plus 2 plus 3 by 2 into x squared plus 4. So now this integration becomes this is now negative half into x squared plus 2 plus 3 by 2 x squared plus 4 into dx. Let's separate the integrals. So first one is negative half is out, and this is 1 upon, I can write it as x the whole square, and 2 is root 2 the whole square into dx plus this is 3 by 2 integration of 1 upon x the whole square, and this is 4, so this can be written as 2 square. Now this we are going to use a formula here, which is integration of, so what is the integration of, this is x squared plus a squared. So integration of x squared plus a squared is 1 by a into tan inverse x by a plus c. So we are going to use this formula on these two. So the first one is now negative half into 1 by a, which is root 2, and into integration is tan inverse x, which is, sorry, tan inverse x upon root 2. So this is tan inverse x upon root 2. This is now 3 by 2 into 1 by a, which is 2, into tan inverse x by 2 plus c. Okay. So further simplifying, this gives me my negative 1 upon root 2. This is tan inverse x by root 2 plus 3 by 4 into tan inverse x by 2 plus c. and this is our integration. Okay, for question number 29, part A, we have to find the integral of 2 plus sine 2x upon 1 plus cos 2x. Now this sine 2x, we know that it's 2 sine x into cos x, and we are going to replace this with 2 sine x into cos x. Now cos 2x in terms of cos is 2 cos square x minus 1, which gives me 1 plus cos 2x is equal to 2 cos square x. So if we replace, substitute this value, so this is 2 plus 2 sine x into cos x upon 1 plus cos 2x is 2 cos square x into e raised power x into dx. Okay, let's separate these terms with the denominator. So this is 2 cos square x plus 2 sine x into cos x upon 2 cos square x into e raised power x into dx. So this gets cancelled, this gets cancelled, this is now. So we are left with 1 upon cos square x is secant square x, and this is tan x into e raised power x into dx. Now this is of the form, now tan x, I can write it as tan x plus secant square x into e raised power x into dx. Now this is of the form integration of f of x plus its differentiation into e raised power x into dx, which is equal to e raised power x into f of x plus c. So this is our function and this is its differentiation. So this becomes e raised power x into tan x plus c. For question number 29, part B, we have to evaluate the definite integral for 1 upon sine x plus cos x for the limits 0 to pi by 4. Let's say this is our integral I, and this is our integral I. So I'm going to get into some standard form. So for that, I'm going to multiply and divide this with 1 by root 2. So this is sine x plus cos x into dx. Okay, 1 by root 2, we can take it out. This is 1 by root 2, and integration of 0 to pi by 4. This is now 1, and now 1 by root 2 into sine x plus 1 by root 2 into cos x into dx. Okay, this now can be written as 1 by root 2 0 to pi by 4 1 upon, now this is sine x, and okay, 1 by root 2 is cos, I can write it as cos 45, plus next is cos b into, I can write it at sine 45 because sine 45 is root. Now this is of the form sine a cos b plus cos a sine b. So which should be equal to 1 by root 2 0 to pi by 4 1 upon sine of a plus b. So I can write it as sine of a plus b, and a is x, b is pi by 4. So this is sine of a plus b. So sine of a plus b with differential element dx. Now this can be written as 0 to pi by 4 with 1 by root 2 out, and this is cosecant x plus pi by 4 into dx. Now we know the integration of cosecant x, which is log of cosecant x minus cot x. So this is now equal to 1 by root 2, and integration is log of cosecant x plus pi by 4 minus log of cot x plus pi by 4 for the limits 0 to pi by 4. So let's simplify it for the limits, evaluate for the limits pi by 4. So this is cot of cosecant pi by 4 plus pi by 4 minus log. So this is log of cosecant x minus cot x. Okay, this is the log. So this is log of cosecant x minus cot x. So log of cosecant x minus cot of pi by 4 plus pi by 4 minus, this is log of cosecant 0 plus pi by 4 minus cot of 0 plus pi by 4. Okay. So this is 1 by root 2, and the log of cosecant pi by 4 plus pi by 4 is 2 pi by 4, which is pi by 2. So cosecant pi by 2 minus cot pi by 2 minus log of, this is cosecant pi by 4. That's right. This is actually in the bracket. So this becomes plus. Let's solve this first. And this is negative log of cot of pi by 4. Okay. Now sine 90. This is cosecant pi by 2. Now sine 90 is 1. So this is 1 cosecant. So this is log 1 minus, now tan 90 is undefined. So this is 0 minus, next one is minus log cosecant pi by 4. So sine pi by 4 is, this is root 2, and log of root 2 minus cot pi by 4 is 1. So finally we have 1 by root 2. This is log 1 minus log of the root 2 minus 1. And this can be written as 1 by 2. And if I take okay, so if I take negative out, this is now log of root 2 minus 1 minus log 1. So this is log A minus log B, which is log A upon B. So this becomes log of root 2 minus 1. And if I take negative to root 2 minus 1 raised power negative 1, so this becomes, if I have to remove negative, so this is now 1 by root 2 and 1 by root 2 log of 1 upon root 2 minus 1. And if we have to rationalize this, this is now 1 by root 2 log of root 2 plus 1. This is always a square minus b square, which is 1. So finally our integral is 1 by root 2 log of root 2 plus 1. Okay, for question number 30, which is LPP based question, we have to find the maximum of z subject to the constraint. So, and for which we have to plot the graph. Okay, so let's plot the graph for this. And our constraints are x plus y 800. So let's say this is our y-axis and this is the x-axis. This be the origin. So I'm going to make a scale of 400, 0 to 400. Let this be after 400, 800, or let it be a scale of 200. So this is 200, this is 400, 600, 800, and then 1000. Similarly, here it's 200, 400, 600, 800, and then 1000. Okay, so first constraint is x plus y. So let's plot the graph for x plus y is equal to 800. When y is 0, x is equal to 800. So our given coordinates for this will be 0, comma 800 and 800, comma 0. Okay, and if we join these, so this will be our line. And this one is x plus y is equal to 800. Okay, next one is 2x plus y is equal to 2000. 2x plus y is equal to 1000. When we put x 0, which gives me y is equal to 1000. So 0, comma 1000. This is 0, comma 1000. When x is 0, y is 1000. So this is 0, comma 1000. And I put y is equal to 0, which gives me x is equal to 500. So 500, comma 0. So 500 is here. So this is 500, comma 0. So if I join these 2 points, it's actually like this. Okay. This is now 2x plus y is equal to 1000. So this is 2x plus y is equal to 1000. Okay, now x is equal to 400 would be here. So this is x is equal to 400 added to y-axis. Okay, now let's get the rest constraints are x and y-axis greater than equal to 0. It's in the first quadrant, so that means the feasible region is in the first quadrant. Now x plus y is less than equal to 800. Let's check it for the coordinate, the origin 0, 0. So if I put x and y 0, which gives me 0 is less than 800, which is true. So that means for the first one, the solution region is towards the origin. And the next one, if we check it for 0, 0, which gives us 0 is less than 1000, so its solution region is also towards the origin. And if I put the coordinate x, so we are testing all these equations for 0, 0. So if we test all these equations for the coordinate 0, 0, this becomes true, this is true, this is true. So that means our feasible region is all towards the origin, and the common region for all these is this one. And we will get the corner points. So common region for all these is this one. And the corner points are, so our corner points are This is the origin O, and the next one is this one. Let's say this is A. So these are our corner points: one, two, three, four, and five. Let's name them. So A, and then B, and then C, and then D. So these are our corner points, and I'm going to write this corner point. The first one is 0, comma 0. Second one is A, which is 400, 0. The third one is B, which is 400, comma 200. So 400, comma 200. C. This is 400, comma 200. And this is OAB, and then C, which is 200, 600, 200, 600, and then D, which is 0, comma 800. So these are our corner points, and we have to find the maximized Z for all these, which is 4x plus 3y. Okay, and for 0, 0, it's 0, and for 400 into 0, this is 600. We will find the value of Z for all these. So 400 into 4 is 1600 plus 600, which is equal to 2200. This is 8, and 800 plus 1800 is 2600, which is this one is 2400. So 0, 1600, 2200, 2600, and 2400, and we have the maximum value at this. So maximize, we have solved this. So the maximum value, maximize Z is equal to 2400 at X is equal to 0 and Y is equal to 800. X is equal to 0 and Y is equal to, so Z maximum is 20, sorry, it's not the maximum value, its maximum value is 2600. So maximum value is 2600, which is at X is equal to 200 and Y is equal to 600. For question number 31, it's given that the chances of P, Q, and R getting selected as CEO of a company are in the ratio 4 is to 1 is to 2 respectively. We have to find the probabilities for the company to increase its profits from the previous year under the new chief executive officers P, Q, or R. And these are the chances of increasing the profits of the previous year. Now, if the company increased the profits from the previous year, we have to find that it was because of the appointment of R. So it's in the ratio 4 is to 1 is to 2. And let's say even with the event that P is selected as CEO or P is appointed as CEO. So let's create the events. So let E1 be the event when P is selected as the CEO. The first one is P. So E1 is the event when P is appointed as E2 be the event when Q is appointed as CEO. And E3 with the event when R is appointed as CEO. Now, they are in the ratio that their chances are in the ratio 4 is to 1 is to 2. So sum of these terms of the ratio is 4 plus 1 plus 2 is equal to 7. So the probability of even getting appointed as the CEO is, the ratio is 4 is to 1 is to 2. This is for P, Q, and R. So the probability of P even is 4 is to 7. Probability of E2 is 1 by 7, and probability of E3 is 2 by 7. Now there is the whole scenario, or the whole thing is going around increasing the profits from the previous year. So let's say A is an event which is for the company's profit increase from previous year. So A is the event when company increases profit from previous year. Now, uh, further is given that the probability of getting the profits under these years, CEOs are zero point 0.3, zero point 0.8, and zero point 0.5. The probability of getting the profits under the first CEO, that is P, is so when P is appointed as CEO, the chances of getting profits from the previous year are zero point 0.3, and when second one is appointed as CEO, the profits probability of getting profits is zero point 0.8, and similarly for the third one, when R is appointed as CEO, the probability of getting profits is zero point 0.5. Now we are going to use here the Bayes theorem. We have to find the probability that if the company increase the profits, so that means the profits are increased, and we have to find it out that it is because of the R. So we have to find this P of E3 by R, and using the Bayes theorem, it would be probability of E3 into probability of A by E3 with all the sum probabilities, that is probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2 plus probability of E3 into probability of A by E3. So let's put in the respective values E3 and probability of E3. So probability of E3 is 2 by 7. So this is 2 by 7 into A by E3. A by E3 is zero point 0.5. And now this is probability of E1, which is 4 by 7 into zero point 0.3 plus this is 1 by 7 into zero point 0.8 plus this is 2 by 7 into zero point 0.5. Okay, I can write this as, so this is 2 by 7 into zero point 0.5, 4 by 7 into zero point 0.3, 1 by 7 into, this is zero point 0.8, 2 by 7 into zero point 0.5. Okay, this can be written as 2 by 7 into 5 by 10 upon 4 by 7 into 3 by 10 plus 1 by 7 into 8 by 10 plus 2 by 7 into 5 by 10. Okay, this is now 5 to that is 10 by 70 upon 4 to that is 12 by 70 plus 8 by 70 plus 10 by 70, which is now 10 by 70 upon 70. 12, 8 is 20 plus 10 is 30. So this is 1 by 7 into 7 by 3. And the required probability, this becomes 1 by 3. So this is the answer, 1 by 3. Okay, for question number 32, which are long answer questions of 5 marks each, and relation R on set A is defined as the ordered pairs x plus y is an integer which is resolved by 2. We have to show that it's an equivalence relation. Now, we all know that The relation is an equivalence when it is reflexive, symmetric, and transitive. So our relation is defined from set A to A. So this is a relation is defined from set A to A, and set A has elements minus 1, 3, minus 4, minus 3, 2, negative 1, 0, 1, 2, 3, 4. Similarly here, negative 1, negative 4, 2, 1, 0, 1, 2, 3, and 4. And this is x and this is y. And the relation is defined as this. So our relation is an ordered pair. X belongs to A and Y belongs to A such that X plus Y is an integer divisible by 2. Now we have to check whether it's an equivalence relation, it's an equivalence relation or not. So first of all, let's check it for the reflexive part. So for reflexive part, we have to take the element with the element and check whether this belongs to the relation R or not. Now x plus x, according to the relation, this belongs to the relation R when the sum of these two is an integer divisible by 2. So x plus x is 2x, which obviously is, and because it's even multiplied by 2, so this is an integer divisible by 2. So this implies that x comma x ordered pair belongs to relation R. Therefore, this relation is reflexive. So this relation is reflexive. Now let's check the symmetric part. So for symmetric, let's consider that x comma y belongs to R, and if we have proved that y comma x belongs to R, then it is symmetric. So x comma y belongs to R, that means x plus y is an integer divisible by 2. So x plus y is an integer divisible by 2 means that y plus x is also an integer divisible by 2. If y plus x is an integer divisible by 2, that means y plus x belongs to relation R. And if y plus x belongs to relation R, that means R is symmetric. So this is symmetric. And let's check whether it's transitive or not. So for transitive, let's say we have x comma y belongs to R and y comma z belongs to R. And if we are able to prove that x comma z belongs to R, then it's transitive. So this gives that x plus y is an integer divisible by 2, and this gives us y plus z. So this is an integer divisible by 2, and y plus z is also an integer divisible by 2. So if this is an integer divisible by 2, this is an integer divisible by 2, that means their sum x plus y, this implies x plus y plus z is also an integer divisible by 2, which gives x plus 2y plus z is an integer divisible by 2. So this is divisible by 2, that means x plus z is also, so this implies that x plus z is an integer divisible by 2, which means x comma z is in relation, and if x comma z is in relation, that means R is transitive. Now we have shown that R is reflexive symmetric and transitive. So this implies that R is an equivalence relation. Okay. If R is an equivalence relation, so next is to find the equivalence class for set. So we have to find all the elements which when added to 2 gives us an integer which is divisible by 2. So that would be minus 4. 2 minus 4. 2 plus negative 4 is negative 2, which is divisible by 2. Then it's negative 2 and 0 and then 2 and then 4. So this is equivalence class for the set. So which is negative 4, negative 2, 0 to 4, negative 4, negative 2, and 0 to 4. This is the equivalence class. Okay, for question number 33. Okay, for question number 33, part A, it is given that the function f of x is equal to x raised power 4 minus 62x squared plus ax plus 9. This attains local maximum value at x is equal to 1. And we have to find the value of a. So let's find out the value of a first. And our function is given as this function is f of x is equal to x raised power 4 minus 62x squared plus ax plus 9. Okay, now this function attains local maximum value at, so x is a point of local maxima. So we can say that at x is equal to 1 is a point of local maxima. And we know that for the critical points, these are the critical points for local maxima or minima, the value of the function at that point is equal to 0. So f dash 1 should be equal to 0. And now let's find out f dash 1. So this is our function, and we have to find its first order derivative first. So f dash x is equal to, this is 4x cubed minus 62 into 2x plus a. And this should be now equal to 4x cubed minus, this is 2 to the 4, 124x plus a. Now, if we have to find f dash 1, we have to substitute the value of x as 1. So this is 4 into 1 cube minus 124 into 1 plus a is equal to 0. Okay, so this is 4 minus 124 plus a is equal to 0, which is negative 120 plus a is equal to 0, and a is equal to 120. So the value of a is 120, and hence obtain all of the points where the given function f of x attains local maximum. So we have got the value of a. So now our function becomes, so this is our function. Now let's substitute the value of a. So this function becomes, this is x raised power 4 minus 124 x raised power 4 minus 62x squared, or let's get the value of f dash x. So our function is now x raised power 4 minus 62x squared plus a is 120x plus 9. And now the first order differentiation is 4x cubed minus 124x plus 120. Now we have to find all other points where the given function attains local maximum, local minimum value. And now we know that for maxima or minima, f dash x should be equal to 0. So that means 4x cubed minus 124x plus 120 is equal to 0. Okay, here 4 is common. So this is now x cubed minus 41x plus 30 is equal to 0. Sorry, this is 4 3 is 12. So this is 31x plus 30 is equal to 0. So this is now x cubed minus 31x plus 30 is equal to 0 is our cubic polynomial, and we have to factorize this. So let's consider this p of x is equal to x cubed minus 31x plus 30, and value of this function at x is equal to 1 is 0. So this is negative 31 plus 30 is equal to negative. This is actually 1 minus 31 plus 30, which is equal to negative 30 plus 30 is equal to 0. So that means x minus 1 is a factor of this polynomial, that is x cubed minus 31x plus 30. Now, if x minus is a factor of x cubed minus 31x plus 30, then let's divide it with x minus 1 to get other factors. So x square, we are using the long division method. This is x cubed minus x square. Subtract them. This this is x square minus 31x plus 30. And now it's plus x, which is x square minus x negative positive minus 31x plus x is negative 30x plus 30. This is negative 30 and negative 30x plus 30. Okay, this is equal to 0. So that means now I can write this x cubed minus 31x plus 30 as x minus 1 is a factor, and the other factor is x squared plus x minus 30. And now we can factorize this x squared plus x minus 30. It can be written as x squared plus 6x minus 5x minus 30. This is equal to x minus 1, and x plus 6 minus 5 into x plus 6. Okay, this is equal to x minus 1, and x plus 6 is a factor, so this is x minus 5. Okay, so now this can be written as this is x minus 1, x plus 6, and x minus 5. X plus 6 and x minus 5. So that means either x minus 1 is 0, x plus 6 is 0, or x is equal to 5. Uh, x minus 5 is 0, which gives me x is equal to 1, x is equal to negative 6, and x is equal to 5. All right. So these are the points of local maxima or minima. These are our critical points. And now let's find out the second order derivative to check these are the point of maxima or minima. So this is f dash x, and let's find out the second order derivative. So second order derivative would be this. For this, it's 12x square minus 124. Now let's check it for check the second order derivative is only for x is equal to 1. So this is 12 square minus 124, which is 12 minus 124, which is 0, which is less than 0. So x is equal to 1 is a point of local maximum. Sorry. Now let's similarly check second order derivative for negative 6. So 12 into negative 6 square minus 124, which is 12 into 36 minus 124, which is obviously greater than 0. So this is 12, 72, 36, 2, 13, and 432. So 432 minus 124, which is 12 minus 4 is 8, 0, 3, which is greater than 0. So that means x is equal to negative 6 is a point of local minima. Now let's check the second order derivative for the other critical point, which is 5. So this is 12 into 5 square minus 124. So 12 into 25 minus 125, 24, which is 50 into 25, which is 300 minus 124, 6, which is greater than 0. So that means x is equal to 5 is a point of local minima. So x is equal to 5 is a point of local maxima, whereas x is equal to negative 6 is a point of local maxima, and similarly x is equal to 5 is also a point of local minima, sorry. For question number 33, part B, it's given that the perimeter of a rectangular sheet is 300 centimeter. It is ruled along one of its sides to form a cylinder. We have to find the dimensions of the rectangular sheet, so the volume of cylinder so formed is maximum. Okay, so let's say this is the rectangular sheet, and let's suppose x be its length. Now it's given that perimeter is 300 centimeter, and we know that the perimeter of the rectangle is given by 2 into L plus B, which gives us L plus B is equal to 150. L is x, so breadth is equal to 150 minus x centimeter. So this is 150 minus x centimeter is the breadth. So length is x and the breadth is 150 minus x centimeter. Now it's given that this is rolled along one of its sides. So let's say it is rolled along the length. So if rolled along length x, so this will be the cylinder. Now, if rolled along x, so the circumference of this circular top or base will be equal to x. So that means 2 pi r is equal to x, and which gives me r is equal to x upon 2 pi centimeter. And the height of this cylinder becomes the breadth. So this will be the height, 150 minus x centimeter. Now we have to find the dimensions so that the volume of the cylinder is maximum. So let's consider the volume as V. So V is equal to pi r square h, putting in the value of r, which is x upon 2 pi square, and height is 150x minus x. So V is equal to, this is pi x square upon 4 pi square into 150 minus x. So this is now 150 x square upon 4 pi minus x cube upon 4 pi. Now for maxima, dv by dx should be equal to 0. So let's differentiate this with respect to x. So differentiating with respect to x, give me 150 upon 4 pi into 2x minus 3x square upon 4 pi is equal to 0. So I'm going to solve this, and let's get the value of x. So I'm just going to take this to the other side because if taking here x common, x cannot be 0, so I'm going to get the value of x. So this gets cancelled. This is now x. This is 50, and which gives me x is equal to 100 centimeter. Now let's check using the second order derivative test that for x is equal to 100, what is the value of the second order derivative? Let's find out the second order derivative. So this is the first order derivative, and second order derivative is now 150 into 2 upon 4 pi minus 6x by 4 pi. So this is now 300 upon 4 pi minus 6x upon 4 pi. This is the second order derivative, and let's check the second order derivative's value at x is equal to 100. So at x is equal to 100, second order derivative's value is 300 upon 4 pi minus 6 into 100 upon 4 pi, which is equal to negative 300 upon 4 pi, which is less than 0. So that means at x is equal to 100 centimeter, v is maximum. Now at x is equal to 100, v is maximum. So let's find out the breadth as well. So breadth was 150 minus x, which is 100, so 50 centimeter. So for length is equal to 100 centimeter and breadth is equal to 50 centimeter. Volume of cylinder is maximum for given parameter, which was 300 centimeter. Right. So these are our values of the length and the breadth. Okay, for question number 34, we have to use integration and find the area of the region enclosed between the circle x square plus y square is equal to 16 and lines x is equal to negative 2 and x is equal to 2. So equation of the circle is x square plus y square is equal to 16. And if we compare this with the standard equation of the circle, which is x minus h the whole square plus y minus k the whole square is equal to r square. So this can be written as x minus 0 the whole square plus y minus 0 the whole square is equal to 4 square, which gives me the center of the circle as the origin and radius is equal to 4. Okay, now let's try to get our coordinate axis and see how this actually looks. Okay, let these be the coordinates 0, 1, 2, 3, and 4. And this is -1, -2, -3, and -4. And 1, 2, 3, and 4, -1, -2, -3, and -4. So our circle goes through these coordinates as, so this is the circle, as the radius is 4. Now the other two lines are x is equal to -2. So x is equal to -2 is a line passing through -2 and parallel to y-axis. So this is x is equal to -2 and this one is x is equal to 2. Okay, so the region, this is the region. This is our region, sorry. Because this is a region that for which we have to find out the area. And this region is enclosed between the limits -2 and 2, -2 and 2, and comes under the graph, or that is the circle x square plus y square is equal to 16, which gives me y square is equal to 16 minus x square, and y is equal to under root 16 minus x square. Now we are considering this region to be symmetrical about the x-axis. So our concerned area or required area here between under the circle x square plus y square is equal to 4, and between x is equal to -2 and x is equal to 2 lines is, so required area is within the limits -2 to 2, and it's y into dx. So because we are considering, so this will give me the area of this region, this one, but we have to find the area of this complete region. So we are considering this region and this region as a symmetrical, so we are going to multiply this with 2. So this is 2 into integration of y into dx. Now the integration y is under root 16 minus x square into dx, which can be written as 2 into -2 to 2 under root 4 square minus x square into dx. Okay. Mhm. Okay, now we are, this is a known form where the integration of under root a square minus x square into dx is given by x by 2 under root a square minus x square plus a square by 2 into sine inverse x by a plus c. Okay. Yeah. Let's use this formula. So this is going to be 2 into x by 2. So this is x by 2 and a square minus x square, which would be 16 minus x square plus a square by 2, which is 16 by 2 sine inverse x by a. Now a is 4, has to be divided for the limits -2 to 2. So this is now 2. Let's evaluate this expression for upper limit. So this is 2 by 2 under root 16 minus 2 square is 4, plus this is 8. Sine inverse 2 by 4 is half, minus 2 by 2 for lower limit. This is 16 minus 4 plus 16 by 2. Sorry, this is, okay. This is 16 by -2 sine inverse -2 by 4. Okay. And this all has to be multiplied by 2. So now into 16 minus 4 is under root 12 plus 8 into sine inverse half. Now the angle for which the value of sine is half is 30. So this is pi by 6 minus, this is -1. So 16 minus 4 is root 12 plus this is now -8, and sine inverse -half. Okay, so this is now equal to root 12 plus 8 pi by 6 minus negative root 12 is negative, and the angle for the value of sine in is -half is negative pi by 6. This all has to be multiplied with 2. So this is 2, open up the bracket, under root 12 plus 8 pi by 6 plus under root 12, and this is minus minus positive, which is, this was actually plus. So this is actually plus. So plus, and which finally becomes plus 8 pi by 6. Okay, so this is 2 times under root 12 plus 2 times 8 pi by 6, and this is 2, and under root 12 is 2 root 3 plus this is 3 8 pi by 3, which finally gives me this is 8 root 3 plus 16 pi by 3 square units. So 8 root 3 plus 16 pi by 3 square units is the required area. Okay, for question number 35, we have to find the equation of the line passing through the point of intersection of the lines. And these are the two lines. So there is a line that is passing through the point of intersection of two lines and is perpendicular to both these two lines as well. And so first of all, let's find the point of intersection of these two lines. Let's say first is the line L1. So which is x by 1. It's given the Cartesian equation of the line is given. And let's say this is equal to lambda. And L2 be the second equation of the line. This is x minus 1 by 0 is equal to y by negative 3 is equal to z minus 7 by 2. And let this be equal to mu. Okay, so now the points that lie on this line would be, if I equate this to, so this becomes, would be of the form multiples of lambda in this form, x is equal to lambda, and equate this to lambda, which gives me y is equal to 2 lambda plus 1, and z is equal to 3 lambda plus 2. And similarly, if we equate here, so x is equal to, this is, if we equate this to nu, so this x is equal to 1, and here y is equal to negative 3 nu, and z is equal to this 2 nu plus 7. Now, if we equate these points, which gives me the value of lambda is equal to 1, and if I equate these, this 2 lambda plus 1 is equal to negative 3 nu. Now, lambda is 1. So, this is 3 is equal to negative 3 mu, which gives me mu is equal to negative 1. All right. So, mu is equal to negative 1. And lambda is equal to 1. So let's find which gives us the point of intersection. We can get the point of intersection. Now the point of intersection of L1 and L2. L1 and L2 is, we can use any of these values and get the point of intersection. Let's use lambda, which gives me x. It has the coordinate x is lambda is 1. So if you put lambda 1 here, which gives me another point 3. If I put lambda 1 here, which gives me 5. So the point of intersection is 135. So this is 135. Now our required line passes through the point of intersection of these two, the point of intersection of these two lines, which is 135. So that means our required equation of line in Cartesian form is, we know that is given by x minus x1 by a is equal to y minus y1 by v is equal to z minus z1 by c. Now we have got the point through which it's passing, which is here x1, y1, and z1, sorry, is 1, 3, and 5. So substituting the values, x minus 1 by a is equal to y minus 3 by v is equal to z minus 5 by c. So this is a required equation of line, and now we have to get the value of a, b, and c. Now our given line, this line, one line is perpendicular to L1. So equation of line 1 is perpendicular to L1, and we know that for that The sum of the product of the direction ratios is equal to 0 when the lines are perpendicular. And here A1 is 1. These are A1, B1, and C1. So this is 1 into A2. A2 is A plus B1 is 2 and B plus 3C. So these are A2, B2, C2, A, B, and C, and A1, B1, C1 are 1, 2, and 3. So let this be our first equation. A plus 2B plus 3C is equal to 0. And the second equation would be 0 into A would be, this would be 0 into A plus, sorry, this is negative 3 into B, so negative 3B, negative 3B, and this is 2C plus 2C is equal to 0. So 1 is perpendicular to L1, we get this, and 1 is perpendicular to L2, we get this. Now our equations are A plus 2B plus 3 is equal to 0, and next one is 0 minus 3B plus 2C is equal to 0. Let's get the value of A, B, and C. So this can be written as, this is 2, 3, 1, and 2. And this is negative 3, 2, 0, and negative 3. Okay, so this can be written as A, 2, 2 0 is 4, negative 9 is equal to B, 3 0 is 0, negative 2, 1 into 3 is negative 3 minus 0. So this is A upon 13 is equal to B upon negative 2 is equal to C upon negative 3. Let's say is equal to K. So A is equal to 13K, B is equal to minus 2K, and C is equal to negative 3K. Let's replace these values in this equation, which was our required equation. So x minus 1 upon A is 13K, y minus v upon B, which is negative 2K, z minus 5 upon C. So z minus 5 upon C, which is negative 3K. And now, if we take out K, so x minus y upon 13 is equal to y minus 3 upon negative 2 is equal to z minus 5 upon negative 3 is equal to K, which gives a final equation as x minus 1 by 13 is equal to y minus z by negative 2 is equal to z minus 5 by negative 3. So this is the required equation of the line which passes through the point of intersection of the two given lines and is perpendicular to them as well. So x minus 1 by 13, y minus z, y minus this is actually 3, sorry. This is 3. Y minus 3 by negative 2 and z minus 5 by negative 3. Okay, for question number 35, 35th part B, we have two vertices of the parallelogram ABCD, and this is question 35th part B, and are given as A, and if the are given as A and B, if the equation of the line through C and D is also given, we have to find the distance between the sides AB and CD, and hence use that to find the area of the parallelogram ABCD. So let's say this is the parallelogram ABCD. All right, and let this be vertex A, which is negative 1, 2, and 1. This is B, which is 1 and negative 2 and 5. And this is A, B, C, D. Now, equation of the line A, this C through C and D is given. So, equation of CD is x minus 4 by 1 is equal to y plus 7 by negative 2 is equal to z minus 8 by negative 2. This is not negative 2, this is 2. Okay, so equation of CD is given and we know that these are the direction ratios. So these are the direction ratios of CD, which are 1, negative 2, and 2. And AB is parallel to CD. We can also get the direction ratios of AB. These are parallel, so the direction ratios will be same. Now the direction ratios of AB is 1 minus of minus 1, which is x2 minus x1. So 1 minus of minus 1. The direction ratios would be of AB would be 1, negative 2, and 2, because AB is parallel to CD, so that their direction ratios should be same. So this is 1 and then negative 2 and 2, because AB is parallel to CD. So whatever are the direction ratios of CD will be the direction ratios of AB, so they have the same direction ratios. Now we can find the equation of AB as it's passing through negative 1 comma. Now equation of line AB, which is passing through, let's say, the point, this is negative 1 to 1, which is our x1, y1, z1, and its direction ratios are 1, negative 2, and 2. So equation of the line is given by x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So this is now x minus x1 is negative 1 by a is 1. So this is y minus y1 is 2, b is negative 2, z minus z1 is 2, and c is 1. So this is the equation x plus 1 by 1, and let's keep it as it is. Now this is the equation of AB in the Cartesian form, and this is the equation of CD. This is the equation of CD. And we have to find the perpendicular distance between them. Oh, sorry. And now we know that this AB is parallel to CD, and perpendicular distance between the parallel lines, if they are in the vector form, let's say the first equation is of the form, let's say a in the vector form, it's a1 vector plus lambda into b vector, and second equation has the vector form a2 vector plus, let's say, nu into b. So here b vectors are same for these because these are parallel lines, and so the perpendicular distance between them, or which is the shortest distance between them, is given by a2 minus a1 vectors cross product with b vectors magnitude divided by the magnitude of b. So let's find out a2. So a2 vector here is, so a2 vector. So a2 vector here is, we have the lines AB and CD. So a2 vector is the position vector of this point, negative 1, 2, and 1. So I can write it as, this is a2 vector, which is negative I cap plus 2j cap plus k cap. So this is the position vector of this, which is a2, because we have these two lines, and this is a2 is the position vector of the point through which the line is passing, and this is the point through which AB is passing, and its position vector is negative I cap plus 2j plus k cap. And A1 is the position vector of the line through which our first line, another line is CD. So its position vector would be A1 will be the position vector through which this line is passing, and this would be 4I cap plus. This is this can be written as y is actually y into, if I have to write this in the standard form, this will be x minus 4 by 1 is equal to y minus of minus 7 by negative 2 is equal to z minus 8 by 2. So this is the point through which this line is passing, and its position vector is 4I cap, and this is negative 7j cap plus 8 cap. So this is A2. A1 and A2 we have got. A1 and A2, and B vector. B vector is the vector uh, which which these lines have common. These lines are parallel to the same vector. The B vector is the vector formed by the direction ratios of these two lines, which would be I cap minus 2j cap plus 2k cap. So this is the B vector. So let's find out the shortest distance A2 minus A1. So A2 minus A1. So A2 minus A1 is now negative I cap plus 2j cap plus k cap. This is A2 minus A1, which is 4I minus 7j plus 8k k cap. And we have to find its uh, modulus, not the modulus, just the A2 minus A1. We have to find its cross product with, so this is A2 minus A1. And our vectors are, okay, so this is negative I cap plus 2j plus k cap minus 4I plus 7j minus 8k, which gives me, so this is negative 5I cap plus 9j cap minus 7k cap. This is A2 minus A1. Now we have to find the cross product of A2 minus A1. Let's find the cross product of A2 minus A1 with B. So A2 minus A1 is negative 5 plus 9j minus 7k's cross, and we have to find their magnitude. So let's find out the cross product first, and B vector. B vector is I cap minus 2j plus 2 cap. So this is I cap minus 2j plus 2k cap. Let's find out the cross product. So how do we find the cross product? Is ijk's determinant for minus 5. This is 9, negative 7, 1, negative 2, and 2. Okay. So this is now equal to I cap. Remove the row and the column for the I cap. This is I cap and this is J cap. Remove the row and the column for the I cap. And we are left with the determinant 9, negative 7, 2, and 2. And one has to be positive, other has to be negative. So this is negative J cap. Remove the row and the column for the J cap. So this is negative 5, negative 7, 1, and 2. And after that, it's plus K cap. So remove the row and the column. This is negative 5, 9, 1, and negative 2. So this is equal to I cap, and 9 into 2 is 18. This is minus 14 minus J cap minus 10 plus 7 plus K cap 10 minus 9. And finally, we have this is 4 I cap negative 3. This is plus VJ cap, and this is plus K cap. So 4I cap plus VJ and K. Let's find out its magnitude now. So the magnitude of A2 minus A1's cross B. So its magnitude is under root the sum of the square of the scalar component 4 square. This is 3 square plus 1 square. So 16 plus 9 plus 1, which is equal to 25. This is 26. 16 plus 9 plus 1. Okay, this is under root 26. But we have to find the shortest distance, and the formula for the shortest distance was we have to divide it with, this is under root 26, and we have to divide it with the modulus of b. And let's find out the modulus of b, which is under root 1 square plus negative 2 square plus 2 square. So this is 1 plus 4 plus 4. This is under root 9, which is equal to root 3. Sorry, 3. So this has to be divided by 3 units. So this is the perpendicular distance under root 26 by root 3 units. And it's given that hence use this to find the area of the parallelogram. Now area of the parallelogram is given by base into height. Now the base here is CD. So CD into height. We have already got the height. Now CD. Base is CD, height is under root 26 by 3. Now CD is parallel to AB, so that means the magnitude of CD is equal to magnitude of AB, and we can get AB. So this is under root 26 divided by 3. Let's find out AB now. So AB, first of all, let's find out the AB vector. So AB vector is position vector of B minus A vector, and B1 minus of minus 1 is 2. So this is 2 I cap, and minus 2 is minus 4 j cap. 5 minus 1 is 4 k cap. And let's find out its magnitude, which is equal to 2 square is 4 plus 16 plus 16, which is 32 plus 4 is 36, which is equal to 6. So AB is equal to 6, and so area is now equal to, this is 6 into under root 26 by 3, 3 to the is, so this is 2 under root 26 square units is the area of the parallelogram. So what we have done here is we find out the equations of AB and CD and got the position vectors in the Cartesian form. And we know that the shorter distance between two lines is given by, if the lines are parallel, then if in the vector form it's A2 minus A1 cross with the parallel vector for both the parallel sides, its magnitude with divided by the magnitude of B, which gives us the height, and the area of the parallelogram is base into height, which we have got as 2 under root 26 square units. Okay, for question number 36, which is a case study based question. And it says that self study helps students to build confidence in learning. It boosts the self esteem of the learners, and recent surveys suggested that close to 50% learners were self taught using internet resources and upskilled themselves. So these are the pictures showing the self study using the books and the internet resources. Now, a student may spend 1 hour to 6 hours in a day in upskilling cell. The probability distribution of the number of hours spent by a student is given below, where x denotes the number of hours. So this is the probability given for the number of hours. And next, based on the above information, we have to answer the following questions. We have to express the probability distribution given above in the form of a probability distribution table. Okay, so first one, let's draw the probability distribution table based on the information given. And it is for 6 hours. So let's make 6 columns. Okay, so this is 1, 2, 3, 4, 5, and 6. Okay, now x denotes the number of hours, and number of hours are 1, 2, 3, 4, 5, and 6. And we have to find the probability from this table. So if I put x as 1, so this gives me x square. And if I put x as 2 in this, so 2 square is 4, so this is 4k. And if I put 3 here, so 3 square is 9, so 9k. And for 4, x is equal to 4, so this is 4 twos are 8k. And if 5 is 5 twos are 10, so this is 10k, and 6 twos are 12k. So this is the probability distribution based on the table, where we have to just put in the values of k and prepare the probability distribution table. So k, 4k, 9k, 8k, and 10k, and 12k are respectively the probabilities of 1, 2, 3, 4, 5, 6 hours. Now we have to find the value of k. So we know that if we sum up all these events, so probability of all the events should be equal to 1. And so if I put in here, so first one is not x squared, sorry. If we put x here, this should be k. So that means k plus 4k, put in the respective probabilities, 9k plus 8k plus 10k plus 12k is equal to 1. So this is 5 plus 9 is 14, 8, 22, and 10, 32, and 12 is 44k. So the value of k is 1 by 44. Now, for question number third, part A, we have to find the mean number of hours spent by the student. So mean number of hours spent by the student, that is, we have to find the mean, and mean is given by sigma pi into xi, where x is the random variable and p is the probability. So let's find the summation. Let's make the product of these. So 1 into k is k, plus 2 into 4k is 8k, 3 into 9k is 27k, plus 8 fours are is 32k, plus 5 into 10 is 50k, plus 6 twos are 12 is 6 twos are 12, and 72k, which gives us, so k plus 8k plus 27 plus 32 plus 50 plus 72. So this is 2 to 4, 7, 11, and 1 is 9. And then it's 3, 3, 6, 5, 3, 8, and 7 is 150. Okay, this is uh, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 1 I think this should be equal to, this is 9 plus 27, it's 36 and 32. So 36 and 32 and 50 and 72. So this is 6, 7, 8, 9, 10, 3, 3, 6, 5, 11, and 7. This is 3, 3, 6, and 5 is 11, and 7 and 1 is 19. So this is 190. So sum of all these is 190. So this is 190k, and we do have the value of k, which is 44, and this gives us 2295. So that should be 95 by 22 is the mean. Now for the same question part B, we have to find now probability when the random variable is greater than 1 but less than 6. So greater than 1 and less than 6, that means we should not take the random variable when it's 1 and when it's 6. So this is included, and let's add all the probabilities. So this is 4k plus 9k plus 8k, and this is 10k. So this is 9 plus 4 is 13, and 8 is 21, and 10 is 31k. So putting the value of k, which is 1 by 44, this is equal to 31 by 44. So this is a probability for a random variable x greater than 1 but less than 6. That is for students who study for more than 1 hour but less than 6. Probability is 31 by 44. Moving on to question number 37. For question number 37, it's given that a bacteria sample of certain number of bacteria is observed to grow exponentially in a given amount of time. And using that exponential growth model, the rate of growth of the sample of bacteria is calculated. This is the number of bacteria cells, and the graph is exponential lag, log, stationary, dead, and this is the time axis. Okay, this is the culture in which the bacteria cells are being grown, and the differential equation representing the growth of bacteria is given as rate of change of P by dt is equal to Kp, with P is the population of bacteria at any given time t. Now, for this, we have to answer the following questions. So let's obtain the general solution of the given differential equation, and we have to express it as an exponential function of t. Okay, so for the first one, uh, its rate of change of population with respect to time is k into p. Now let's integrate this to get the differential equation. So integrating on both sides we get. So if we integrate on both sides, this is dp by dt is equal to integration of kp, or first of all, and let's rearrange it. So this can be written as, let's make it dp by p is equal to k into dt. And now let's integrate this. So this integration of this on both sides will be dp by p and integration of k into dt. So this is log p is equal to k is out, and integration of 1 into t is t. So this is log p is equal to k into t plus c. Okay, so we have got log p is equal to k into t plus c, and we have to write this as the exponential function of time. So P is equal to e raised power kt plus c is the general solution of the given differential equation. So P is equal to e raised power kt plus c. Now, for question number two, it's given that if population of the bacteria is 1000 at t is equal to 0, so we are going to use this equation. It's given that when t is 0, P is 1000. So if we put both these values in this equation, so P is 1000 and e raised power k into t is 0 plus c. So this is 1000 is equal to e raised power c, and which gives me, so this is, I can write it as log 1000 is equal to c, and log 1000 is equal to c. So I can write it as log, this is 10 cube is equal to c, so this is 3 into log 10 is equal to c, which gives me c. Now log 10 is 1, so c is equal to 3. Okay, now we have to find the population of bacteria is 1000 at t is equal to 0 and 2000 at t is equal to 1. We have to find the value of k. So let's put once again, use this equation now. The population is 2000 is equal to e. T is 1. We have got the value of c, which is 3. We have to find the value of k. So this is 2000 is equal to e raised power k plus 3, which should be equal to log 2000 is equal to k plus v. Now the value of k, I can also use, we have to find the value of k. So and let me use the value of c as log 1000. So this is, let's say log 1000. So let me just keep it as log 1000. So it's easier here. So this is, let's say log 1000. So this is log 1000. And now this becomes log 2000 minus log 1000 is equal to k. So this is log a minus log b, which is log 2000 by log 1000 is equal to k. And the value of k is equal to log. So the value of k is log. Moving on to the last question, that is question number 38. Okay, for question number 38, it's about the scholarship, that is money provided to a student to help him or her to pay for education. And some students are granted scholarship based on their academic achievements, while others are rewarded based on their financial needs. So every year, a school offers scholarships to girl child and meritorious achievers based on certain criteria. And it's about the session 2022-23 that the school offered monthly scholarship of 3,000 to girl students and 4,000 each to meritorious achievers. So totally now there are 50 students, including the girl and the meritorious achievers, and the monthly expenditure incurred by the school on scholarships was 1,80,000. We had to express the given information algebraically using matrices. So let's get the linear equations for this. So let's say x be, because there are two types of students, the girl child and the meritorious achiever. So x be number of, let's say, girls, and y be the meritorious achievers. Okay, so they are total of 50. The first equation is x plus y is equal to 50. And now it's given that 3,000 is given each to the girl child. So number of girls are x. So 3,000 into x is the expenditure on girls. And 4,000 for the meritorious. So 4,000 into y is for the meritorious. And that is, the sum total is 1,80,000. Okay, if we can take 1,000 common in this. So this is 3x. plus 4y is equal to 180. So these are two equations, and algebraically, so express the given information algebraically using matrices. So if we have to solve the matrices x plus y is equal to 50, and the second one is 3x plus y is equal to 180, we can express them algebraically as ax is equal to b, where a matrix is the coefficients of x and y, this is 1, 1, 3, and 4, and x should have the variables. We have two variables, x and y, and b has the constants, which is 50 and 180. So this is how we express the equations. ठीक है. Okay, so we have got the equations in the matrix form, and next question is we have to check whether the system of given matrix equations is so obtained is consistent or not. That is, we are going to get the solution from this or not. And so consistent means equations with a solution. Now for that we need to find the A inverse. If A inverse, sorry, determinant of A, if determinant of A is not equal to 0, that means the given system of equations are consistent. That is, we can use them to get the solution, and our A is 1, 1, 3, 4. We have to get the determinant. It's through second order determinant or the matrix. So 4 minus 3 is equal to 1, which is not equal to 0. So we can see that system of equations that we have got are consistent. System of equations are consistent. Okay, next is find the number of scholarships of each kind given by this. That is, we have to find the value of x and y. So for question number third, part A, we have to solve this. So our system of equations was ax is equal to b, and to get x, this is equal to part of a inverse into b. Now to get the a inverse, which is of second order matrix, so it's easy. You just have to swap these two elements, that is, let's swap to get the A inverse of the second order matrix. Shortcut is to swap these two elements, that is 4 and 1, and change the sign of these two, so that it would be -1, -2. So this is our A inverse. So inverse is 4, -1, -3, 1. And now we have to find its product with B is 50 to 180. So this is equal to, so 4 into 150 is 200, and 1 into 180 is -180. This is the first element. Minus 3 into 50 is -150 plus 180. So 200 minus 80 is 20, and -150 plus 180 is 30. And xy is equal to 20, 30. So that means number of girls are 20 and number of meritorious achievers are 30. Okay, so we have got the number of scholarships of each kind given by the school using matrices. So 20 are for girls and 30 are for meritorious achievers. And now, had the amount of scholarship given to each girl, child, and meritorious student been interchanged, what would be the monthly expenditure? So we have to change the amount of scholarships given. Initially, it was 3,000 for girls. So now it's 3,000 for meritorious achievers. So this is 3,000 into 30. And initially, which was given to the girls, this is given to meritorious achievers, and for meritorious achievers, it's now given to girls. So this is 4,000 into 20 for girls. So just interchange them. And this is 3 3 the 9. This is 90,000 plus 4 to the 8, this is 80,000. Now the monthly expenditure would be 1 lakh 70,000. So 1 lakh 70,000 should be the required expenditure if we change the expenditure that was initially given to girls and the meritorious achievers. So with this, we are done with this paper code 6531 of 2024. Thank you for watching. Do like, share, and subscribe.